Imagine we're going to the market by walking 30 meters straight and then take a left turn for another 40 meters walk. The total length of path traveled can be defined as distance, and in this case, 70 meters is the distance from our home to the market. Now, what is displacement? Displacement is the shortest distance from our home to the market. If we look at this figure closely, we can see that this path forms a right triangle. Thus, we can calculate the displacement by solving the hypotenuse of the triangle using the formula c squared equals a squared plus b squared, where a is the base of the triangle, b is the perpendicular, and c is the hypotenuse. Inserting the values, we get c squared equals 2,500 meters, c equals square root of 2,500, which is equal to 50 meters. Much shorter than the actual distance of 70 meters. The other difference between distance and displacement is that distance is a scalar quantity, which means that it only measures magnitude, while displacement is a vector quantity, which include both magnitude and direction. So, when talking about displacement, we also need to mention its direction. Therefore, the distance is 70 meters and the displacement is 50 meters northeast. If we want to know the travelled distance of going to the market and coming back, we will need to sum up the numbers. 40 meters plus 30 meters, plus another 30 meters going back, plus 40 meters to home, for a total distance of 140 meters. Whereas the displacement will be 0. Can you tell us why? If it took us 100 seconds to reach the market, we can also calculate our speed. Speed can be defined as a rate at which something moves, and can be calculated by measuring distance travelled in a particular time period. The equation can then be written as speed equals distance over time, which would then give us 0.7 meters per second. Since it's a scalar quantity, speed only contains magnitude. Velocity, on the other hand, which is defined as the rate at which an object changes its position, consists of both magnitude and direction. It can be calculated by measuring the rate at which an object is displaced in a particular time period. Velocity equals displacement over time. In our example, this would yield 0.5 meters per second northeast. Don't forget to write the direction, as velocity is a vector quantity. To conclude, both displacement and velocity are both function of position. The magnitude depends on whether an object changes its position and how far it is from this starting point.